The Java generator, which the JPA is just a specialization of, is an event-driven generator. That means that when it runs through the meta model, it will find the meta classes. I will say, okay, should I generate for this one? Okay, I should. Then it will generate a class event that the various listeners then can act on. And it will generate meta property events and meta association events and so on. These event listeners I've configured here. It's just a bunch of them. We have a huge pile of listeners built in, and you can create your own. It's really easy. I have some built-in listeners, which allows me to just write date in my model or big integer in my model, and then we'll insert the java.math.big integer or java.util.date and so on. I have the JPA, generator event listener, which will insert all the JPA annotations. It will look at the associations. Just to give you an example, here we have customer, which has a one-to-many composite association to an address. It will look at this and say, okay, that's a one-to-many. I will take and generate a field called private set, and then use generics and say it's a set of addresses. I'll call it an address collection because it hasn't been given a name, and it will just use the default naming scheme. You can decide what you want, and you can use role names here to specify it otherwise, and then it will initialize that, and it will set up the one-to-many association. And if it's bidirectional, it would do the correct mapping and say, okay, then there's a many-to-one from address to customer, and we'll set this one up as the owner and the other one as a map by. All the standard JPA, it will do that for you. You don't have to think about it. It will see that this is a hierarchy, so it'll insert discriminator columns, and that's again the inheritance strategy. You can use that to specify different settings. Okay, back to this. We have some serial version we can put on. Some meta type Java listeners. We'll put in a lot of metadata from the UML model. That can be really nice when you look at it in the beginning. You can turn it off later on when you're familiar with it all. You'll put on some property sugar method event listeners, like instead of calling object.set, then you can say object.with or .add2 without actually inserting any semicolons. Put in a hibernate delete offense listener, and then a really cool one is called a bidirectional generator event listener. So if you look at this association between customer and address, it's bidirectional. So that means if you have customer, if you add an address to a customer, then the address should also know about the customer. That's what you mean when you say it's bidirectional. You can navigate it in both directions. But it's tedious in Java code because Java memory is unidirectional, so is .NET memory, to say, okay, customer.address and address.set customer. So we'll do that for you. We'll generate in code to maintain all this bidirectionality in memory. Then you'll set up a code writer, and the code writer is actually responsible for writing out the transform. You transform the meta model into a Java model in memory, and when everything is done, you'll take this Java model and then you write it out to the file system using a code writer. Here I'm using a Jalopy formatting code writer, saying to put it into the generated folder, and then I'm specifying a package rewriter, and the package rewriter will allow me to specify what package things should belong to. And if you look briefly into the project browser in the Enterprise Architect model here, you'll see it's called model. It's not called DK Tiger Team or my company.my project or anything. It's just, you could put that in and then leave up the package rewriter, but I like to keep things simple in here because I could actually create two different products using the same model with various mappings and different generation setups. So here I can say that if it starts with model, then I'll rewrite it to DK Tiger Team MDSD demo.model and so on. That's just the configuration from this line to here. It's just setting up what do I want, how do I want things to be changed. So that's not that much code, and then the real hard work goes on here, and This is just like 5 lines of code. So you take an Enterprise Architect XMI reader, which can read in the XMI format from Enterprise Architect. And then you say, I would like you to read in from the model XML file. That will give you back a meta model, which is the root object for the entire meta type data structure that the UML represents. When you have that in, then you'll just ask the Java generator to execute on the meta model using the code writer. What that will do is that it will perform the transformation from meta model to Java model. It will apply all the event listeners. They can do whatever they like. And when all of them are done and all the classes have been created, it will write them out using the code writer. This is 2-in-1 process. And it will return all the classes it generated, which is needy because we would like to generate a JPA specific XML file called an ORM XML, which will list all the entities. So we'll do that. We'll create one here. We'll ask it to generate, and then we'll write out the XML document to the generator folder, to a meta-inf subfolder, and the file we'll call that ORM XML. Moving along quickly, we'll just run the demo generator as a standard Java application. Show the log, the console, and we're done. So now we'll go to the generator, press F5 to refresh it. You'll see it contains the ORM XML. Just show it briefly here. Contains all the entities. I don't want to change it. I'll save it. And we'll just look at some of the classes here. You can take customer, for instance. We'll just take a customer, we'll look at it. This customer inherits from abstract entity, applies the entity annotation. It has a many-to-one to a clinic. It has the Java documentation. It has a one-to-many. It's a set of invoices called an invoice collection. It's one-to-many and it's mapped. All you see down here, if we take the get, let's just get invoice collection. And you see we create a bidirectional one-to-many wrap setter, which will handle everything for you, and it will do the inverse on the invoice. In the get customer, then you'll have the set customer down here where you have a many-to-one wrapper. And if you take the address, you can see that it is an entity. It has an inheritance strategy, discriminator column and everything. And if you pull up a quick hierarchy, you can see that it has Danish address and international address. This was a very brief demonstration of what the TigerMDSD tool can do. Please don't hesitate to contact us if you have any questions, and thank you for watching. Goodbye.